Okay, good. Good morning, everyone. My name is Lakitazi. I am your presenter for Natural Sciences, Grade 5. Please follow me on Twitter. Here's my Twitter handle. It's Lakitazi. And I hope to see maximum participation. And I hope to see more students today. And yeah, good luck for the lesson. Let's start our lesson. Good. Okay, on the previous lesson, we learned about burning fuel and how to prevent fire. And what can you recall about about the prevention of fire? Can you type in your chat box? What do you recall about the prevention of fire, or how to prevent yourself from fire, or any safety tips that you remember? Can you type in your chat box 4 safety tips, please? Thank you so much, Faith. Okay, Peter. Thank you so much, Peter. It's my first time seeing you in in this class. You're welcome, Peter. Then Kia, yes, Kia. Then praise, definitely. Lesejo, yes. Um, okay, then okay, thank you so much. Let's okay, Ethan. Okay, thank you so much, Ethan. Okay, Karen, it's your first time. Welcome, Karen, to our class. Faith, thank you so much, Faith. Rashile, good one, Rashile. Oh, okay, Irene, good one. Okay, Monique, Irene. um, Serene, it's my first time seeing you. Welcome to the class. I hope I have pronounced your name correctly. Welcome to the class. Oh, Amanda, you just gave me a bucket list. Thank you so much, Amanda. Buhle, good one on your side. Leletu, I know Leletu. What's happening? Okay, thank you so much, guys, for your responses. Let's go to our next slide. At the end of the lesson, the objectives, you will know about what to do, what do cells and batteries do, what is an electric circuit, where does energy come from in a power station, and also you know how does electricity get from a power station to where it is needed, and you also know how can we use electricity safely. And so these are the objectives for today's lesson. And yeah, let's move to the second one. Okay, batteries come in small shapes in different sizes. As you know, there are bigger sizes, there are smaller sizes. Let's take, for instance, a cell phone battery is small. A car battery is bigger than a cell phone battery. Okay, therefore, batteries come in different sizes and different shapes, and also batteries come in different volumes. Okay. Okay, batteries are needed for many different purposes, mostly torches, radios, calculators, cell phones, some toys, and even cars. Okay, pacemakers and hearing aids. Okay, then good. As we can see here, this is a car battery with two terminals, which is bigger than these batteries I'm going to show you now. Okay, these are different batteries as well compared to the car battery. Okay, batteries are useful because they store chemical energy when the battery is connected in an electrical appliance and the appliance is switched on. The stored energy in the battery is transferred to the appliance in the form of electrical energy to make it work. Okay, therefore, it's important for us guys to know that as well, that a battery has a positive has a positive and a negative terminal. Okay, then I'm going to show you this further as we continue with our lesson. As I go through our chat box. Okay. Then most of you guys know we did a lesson on circuits and we also did a lesson on batteries, right? An electrical circuit is a system that consists of different parts. I am going to show you two pictures here of how an electrical circuit or an electrical diagram works. Okay, we call these parts of components the circuit of the circuit. For example, batteries, light bulb is also there in a circuit. Connecting wires are components that make up a circuit. When these components are connected the right way, okay, in a right way, electricity will be transferred from one component to the other. So this is a a diagram of a circuit. As you can see, there's a battery, there's a light bulb, there's a switch, then there's a, okay, then these blue lines, they are wires. Okay, let's look at this battery here. There's a plus sign or a positive sign, and also there's a negative sign or a minus sign. Okay, in this example, okay, the electricity would be transferred from the batteries through the connecting wire to the bulb and back through the wire to the batteries to complete the circuit. And as well, if there might be a wire break here, let's say if a wire has a cut, okay, therefore there won't be any electrical flow. Okay, then this is a simple diagram of a circuit. It's similar to the picture you saw now before this one. This is a simple diagram of a circuit. Okay, as you can see, this round part here, or this round shape, it's a symbol of a light bulb. Okay, then these lines here, these black lines, they symbolize wires. Then, as you can see here, there's a line going up. This is a switch. Okay, therefore you can see that this switch has, pardon me, this switch is off. As soon as the switch is on, this line will go down here and connect with this switch down here. Therefore, this is a switch. Then this is a this is a battery. The long line shows that this is a plus or a positive sign of the battery. Then the short line shows us that this is a minus, okay, or a negative sign of a battery. Therefore, the long line, it's a plus or a positive. Then this one, it's a negative or a minus. Then this is the simplest way to draw. This is the simplest way to draw a circuit. Okay. Whenever you are requested to draw a circuit, the simplest way you can do it is to draw this diagram. Okay. As I go through our chat box to check for any questions. Okay. Good one. Uh, okay, good. So, guys, can you tell me what comes into your mind when you see this picture here, or when you see this diagram here? I can call it a diagram, you can call it whatever you want, but what comes into your mind when you see this picture here? Can you type in your chat box? Then I'm going to review your answers. Okay, some of you are saying, okay, good one. You see a power station. Okay. You see electrical transmissions. Okay, good. Okay. Okay, good one on your side. Good. Okay, Akani. Kia, yes. Monique, yes. Uh, Faith, definitely. Bonono, okay, yes. Rashile, okay. Oratile, yes. Lisedi, yes. Okay. Okay, Monique says we are going to shut at ESCOM if they take. Okay, okay, good. Okay, let me give you my own understanding of this diagram. Okay, this is a power station. As you can see, okay, we're looking on the top side of this picture. This is a power station. As you can see, this structure here, this blue building here, okay, this is a power station. Therefore, that's where electricity starts, okay. Coal is converted into electricity from a power station. Then through a power station, it travels from the power station through the transmission lines. These three polygons are called the transmission. They transport electricity, or they transfer electricity. Therefore, these transmissions, they provide us with electricity. Then from the transmissions, the electricity that we get, it goes through a substation. From the substation, it goes to an electricity box. Maybe most of you are familiar with electricity box where you stay. Probably in your street there's electricity box. Then this electricity box, it gives us electricity to our homes, our schools, our shops, and all sorts of places. Okay. Okay. Faith. Faith says first it's a power station, then the polion, then the substation. Yes, definitely. Good. Okay. Um, that guesses how many houses can an electricity box hold. It will depend, Kia, on the. It will depend, Kia, on the volume of the electricity box. Okay, some suburbs or townships have small electricity boxes, but some townships and suburbs have big electricity boxes. It depends when it comes to the location. But thank you so much for your question, Kia. I Bunono, no. Please watch your language, Bunono. Okay. Then let's go through this one of electricity. Okay, from a power station, electricity is transferred through transmission lines held up by polons. As you have seen in the previous slide, that electricity was coming from a power station and it was transferred through polons, those three polons. Okay, the transmission lines are part of the circuit that connects the power stations to where we need to use our electricity. Therefore, our electricity will travel from the power station through polons, through substations, and back um, uh, uh, um, to different locations. Okay, okay. This is a picture of different polons and the voltage that they can carry. Okay, then the biggest voltage that they can carry, it's this one. Okay, it's 735 kilowatts, meaning that this is the biggest polyon thus far. Okay, then it goes down to the other one with 315 kilowatts. Then the other one, it carries 315 as well kilowatts. The other one carries 161 kilowatts. Then the smallest, it carries 69 kilowatts. Therefore, each and every transmission line holds its own power. Okay, right. The transmission line carry large amounts of electricity to substations in cities, in towns. Okay, as you can see here, this might be an electricity box. Okay, this will be an electricity box. Okay, okay, let me go through our chat box and check if there's any questions. Mm, Okay, let's look at the safety, electrical safety tips. Okay, do not put on the cord to an unplugged appliance. Okay, hold the plug and pull. Do not pull on the cord. Okay, to unplug the appliance. Hold the appliance and pull it nicely. Okay, dry your hands before you plug in or unplug a cord. Do not hold a cord with wet hands. Okay. If a plug is broken or a cord is cut or worn, okay, do not use it. Okay. Whenever you can see that this cord has been cut or has a fault, do not use it at all. Okay. Okay. Then do not plug too many cords in one outlet. Do not plug too many cords in one outlet. Do not overload the cord. Okay. Keep appliances away from water. Do not use hair dryer if there is water nearby. Okay. If there is an electrical storm with lightning, turn off and disconnect electrical appliances like the TV and your computer, and do not touch your phone. Okay. Never touch any power lines. Okay. Some power lines are buried under the ground. If you are digging and find a wire, do not touch it. These are our electrical safety tips. Okay. Do not put anything into an outlet except a plug. Good. Okay. Now it's your turn. Okay. We use electricity every day. Electricity can be dangerous, so it is important that we use it safely. Electricity can give you an electric shock. An electric shock can hurt you badly or even kill you. Okay, what is wrong in this picture? What is wrong in this picture? Can you type in your chat box what is wrong in this picture or with this picture? Okay. A baby can burn herself and electrocute herself. Yes. Yes. Elijah. Samuel. Yes. Faith. Yes. Bonono. Yes. Rashile. Yes. Okay. What about this one? Okay. What about this following picture here? What is wrong in this picture? What is wrong in this picture here? Okay. Thank you so much, Akani. Okay, Uratile, yes. This is so dangerous because we don't know if this pot is holding a hot substance inside or what. Therefore, that is completely wrong. Good. Any safety tips for these people here? Or yeah, let's start with this one. As you can see, there are three people under the tree. Any safety tips that you might want to give them? Any safety tips for these people here under the tree? Any safety tips? Any three safety tips or one safety tip? Safety tip. Okay, Monique says, don't stand under the tree when there is lightning. Yes, thank you so much. Faith, yes. Lesejo, yes, I agree with you. Sorry about that, Amanda. Okay, good. What about these two boys here? Any safety tips? Any two safety tips for these boys here? Oh, good. Thank you so much for your brilliant answers. Definitely good. Okay, thank you so much, guys, for your participation and your contribution with regards to our activity. The takeaway message for this class is for this lesson was never play with electricity. A circuit has a light, a switch, and a battery. Okay. Follow the safety tips all the time. It's good to follow all the safety tips all the time. Okay, here's a link you can follow. Okay, based on this content that we covered today. And also, our next class, here's an invitation. We are going to continue with energy and movement. Good. So if you do have any questions, please send me an email like Kazi. Follow us on social media at African Teen Geeks at DVE_SA, hashtag Sasol Foundation at Sasol SA, hashtag STEM Champions, hashtag Lockdown Eschools. And thank you so much for contributing to this lesson for today. And from my side, it's goodbye.